Greetings, fellow Meccas. Today, we're going to be looking at challenging limits. The problem. Evaluate the following limits. Part A. Limit x squared minus 6x plus 8 divided by x squared minus 4 as x approaches 2. And part B. The limit the square root of x minus 1 divided by x minus 1 as x approaches 1. Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you're able to solve this problem. Now let's work on it together. So for part A, can we use direct substitution to solve this problem? Well, let's check our denominator. If it does not equal 0, we're good to go. We plug in 2 in our denominator, we get 4 minus 4 or 0. Oh, we have a problem. It's undefined. However, is there another way to solve this limit? What if we factored? Well, if we factor the numerator, we get x minus 2, and we need x minus 4 on the numerator, and then our denominator is going to be x minus 2 and x plus 2 we factored. And if we simplify or cancel out like terms, we get x minus 4 in our numerator and x plus 2 in our denominator. So now if we check again our denominator to see if the limit as x approaches 2 does not equal 0, we just plug in 2 and we get 4 in our denominator. Therefore, a limit exists. So, since we know a limit exists, let's find the limit. Well, we're going to get the limit x approach 2, x minus 4 over x plus 2 is going to be equal to, we plug in 2, we get negative 2 over 4, and then we get, this is going to be equal to negative 1 half. So that is going to be a solution for part A. So the limit x squared minus 6x plus 8 divided by x squared minus 4 as x approaches 2 is equal to the limit x minus 4 divided by x plus 2 as x approaches 2, which is equal to negative 1 half. And that is the solution for part A. Now for part B, the limit the square root of x minus 1 divided by x minus 1 as x approach 1. Can we solve this problem just by plugging in 1? Well, let's check our denominator. We plug in 1, we get 0, undefined. Well, is there another way to solve this? Well, there is another way. We can times the numerator by the conjugate of the numerator. So what's the conjugate of the square root of x minus 1? Well, the conjugate is the square root of x plus 1. So if we times our numerator and denominator by that, we get square root of x plus 1 times the square root of x minus 1. And then we get, on the denominator, we get the square root of x plus 1 times x minus 1. If we expand the numerator of this, we get x, we get negative square root of x, we get plus the square root of x, and minus 1. And we get, on the denominator, we're not going to do anything. It's square root of x plus 1 times x minus 1. Now if we simplify the numerator, we can cancel this. We get x minus 1 divided by the square root of x plus 1 over x minus 1. And then we can cancel out like terms. That can cancel. So this is going to be equal to 1 over square root of x plus 1. Now how can we find our limit at 1? Well, if we plug in 1, so the limit as x approaches 1 of 1 over the square root of x plus 1, does our denominator equal 0 here? Let's see if we get 1 plus 1 or 2. It does not, so we're good to go. So we put this, if you can plug in 1 here, we get 1 over 2, and that is going to be our solution for part B. So the limit, the square root of x minus 1 divided by x minus 1 as x approaches 1 is equal to the limit of 1 divided by square root of x plus 1 as x approaches 1, which is equal to 1/2. And that is the solution to the problem. I hope this video helped. If it did, please consider subscribing and liking